Good morning, everybody, and welcome to this seventh seminar organized by the Italian Reproducibility Network with the support of the Italian Italian Association of Psychology, AIP, which we thank you very much for their support. First, if you want to become a member and if you want to support the Italian Reproducibility Network initiative, you can become a member of the association by subscribing to it. Or if you wish, you can also subscribe to our emailing list and being updated with all of our initiatives. Now, let me, before starting with today's seminar and presenting you with today's speaker, I'm going to provide you with some indications about the question and answer session. You can indicate that you want to ask a question by writing the word question within between square brackets in the chat, and we will give you the floor. Or if you wish, you can write your question in English or either in Italian, and also within square brackets, and then we will read it aloud and translate it as needed. And finally, if you are a PhD student, please signal it because we'll give you priority to your questions. Now, let me introduce Alex Holcombe, who is going to take today's seminar, and thank you very much for being here. And the seminar is entitled Contributorship, Changing Practices to Better Credit Researchers. Alex is a professor of psychology at the University of Sydney. He has been involved in reforming researcher practices in science through initiatives such as the web app Tenzing, the creation of journal advances in methods and practices in psychological science, the Association for Interdisciplinary Meta-Research and Open Science, the Free Journal Network, Registered Replication Reports, PLOS ONE, and the Wiki Journal of Science. As well as doing meta-science, Alex conducts psychology experiments on topics such as how humans keep track of moving objects. Alex, you're very welcome, and the floor is yours.
Thank you, Michaela. And it was good to, it's great to hear about everything that you all have been doing in the Italian Reproducibility Network. Thanks a lot for inviting me to talk about this. I'm really interested to hear your reactions and your experiences around this. I think most researchers, even PhD students, have come in contact somewhat or learned a bit about the authorship system that is sort of the currency of academia. And what I want to argue is that we should be changing it, moving it towards what I call contributorship, because it really isn't set up for what we need it for now. So, you know, when modern science started in maybe the 17th century with things like the Royal Society, and you had Galileo and then people like Newton, and you had science that supposedly was being done by these sort of aristocrats, these European gentlemen. They must have been helped by people, but nobody talks about that. What it was all about was they would write letters to each other, and eventually those became journal articles. And the idea was that, yeah, there was one sort of genius or important person who had done the work. And so, of course, they're the ones who wrote up the paper, and thus their name was the only name that was attached to it. And, you know, that made some sense, perhaps, in the very beginnings of science, when you did only require one person to do almost any scientific project. But things have changed. As you may know, and you can see in this slide, the average number of authors per paper has rapidly increased, and this graph only goes to 2012, and it's continued increasing. So that it starts to become unwieldy, the idea of centering it around the concept of an author or like a writer of the paper, when these scientific projects have become more and more complicated. So I suggest that we think of it in terms of the contributors, not like the authors, because at least in English, the word author is very attached to the word writer. What we need to do now is not just give credit to like the elite person that might have been the original function of all of this, but rather we need to know who did what in scientific projects. And that's true for like a couple reasons. One is just justice. We want to recognize people for what they do, but also, from a more pragmatic, bureaucratic perspective, you can say we need to know who did what in a scientific project because of resource allocation. All of these funding agencies and universities that I'm sure you also have in Italy, they have to make decisions about who they're going to give money to. And the taxpayers are charging them with getting good science done. And so in order to decide who to give the money to, they need to look at the track record of past scientific successful projects and use that to figure out what teams of researchers should be given the next round of funding to. But as I said, authorship is not really about that classically. Instead, you'll see in authorship criteria, not just things about, well, we need you to list on this paper who the people are and what they did. Instead, you'll see things like intellectual contribution being important, and they're also quite writing based, which, as I say, I think it might have made sense back when hundreds of years ago when it was just these people who were doing everything. And I was acculturated to this pretty quick when I started my PhD. So here's the building that I did my PhD in, William James Hall. And when I joined the PhD program, I was excited to try to make a contribution. And, I didn't know much about the research topic that I was going to be working in. But one skill I did happen to have already was computer programming. So I happened to be at actually where they had sherry hour at the top of this building one Friday early in my PhD, and when you're sort of drinking with these professors, and one of them during the conversation mentioned that they need this experiment programmed, and so I thought, oh great, I can help and I can start contributing to these teams this way. So I talked to him about programming it, offering to do so. But then as the conversation continued, it became clear that, he said, well, I don't give authorship for, programming. I can pay you. So at that moment, then I really got the message that these like technical skills aren't really what's valued. Instead, I was pushed, instead of becoming like a specialist, like maybe specializing in programming, and back then that would have been great if a lot more people specialized in programming, because with the rise of bioinformatics and big data, we would have been more productive by now. But instead, I was pushed to be what we call a jack of all trades in English, meaning that the idea is that universities hire these sort of principal investigators that like know about every aspect of the project and are capable of all of them, and train, and then end up training other people to do all of them. So this really inhibits specialization. But in any field, I would say that we really should be encouraging specialization rather than inhibiting it by only giving credit to these sort of intellectual contributions, which is a very subjective term. So this was the importance of encouraging specialization was recognized even at the very beginning of the Industrial Revolution, before you had things like factories that made it even more obvious. So, for example, Immanuel Kant, the philosopher, said already in 1785 that everything is profited from the division of labor. If any worker sticks to just one particular task or kind of work that needs to be handled differently, they'll get better and better at that particular task, and they'll get much better than anyone could if they were trying to do all the different tasks. If they're trying to do all the different tasks, the crafts remain at an utterly primitive level. And if you even read Adam Smith's The Wealth of Nations, in the very first page, he talks about the importance of specialization and how this is going to lead to a lot more productivity. But in science, we ignored this. We didn't encourage specialization. We stayed attached to these authorship criteria. Let me give you a very let's see the actual specifics of authorship criteria here. So the International Committee of Medical Journal Editors they got together starting in the early 80s, I think, to try to set standards for medical journals. And then because they were sort of the first in science, hundreds of science journals, including in psychology and other fields, basically just used their authorship criteria as a model. So this is the most influential authorship criteria in science. And they currently, it's been revised over the years many times, but it currently recommends that authorship be based on the following 4 criteria. So they say, yeah, doing a lot of the work, they're doing some part of it. Yeah, that's important. Okay, so that's good. That's the kind of thing I'm looking for. But you'll see there's also this and. So it's not sufficient to make a substantial contribution to the conception or design of the work. There's this and here, which I put it in all caps. You have to also draft the work or revise it critically for important intellectual content. So here we see the writing-centeredness of it. You can't become an author, have your name listed on the paper in the byline, unless you contribute to the writing. And they also throw this intellectual thing in there, which again is a subjective thing, which I worry historically has been used to exclude certain people, because when you have any kind of wiggle room, then people with power will indulge their own prejudices and biases. And then you have this just little one. All authors should approve of the version to be published. That might be okay. And all authors should be accountable for all of the work. So as we increase so despite this hindrance of specialization, that everybody was supposed to be able to contribute to the writing, and everybody was supposed to be able to account for all of the work. In other words, they had to understand all aspects of work technically in order to qualify as an author, at least if they're going to follow these regulations. That would hinder specialization, because the more complicated the work is, you're not going to be able to understand all of it once science advances. Now, of course, nevertheless, science did advance somewhat. I just think it's advanced a lot slower than it could have otherwise. And now we're at a point where this is getting ridiculous, because for many projects, you need dozens of people, and it's not practical for all of them to contribute to the writing of the work or to understand what everybody else did. So I say we need to move away from this. Just some examples of the kinds of scientific activities that are done that might involve specialization, in which, I might be an author on a paper with some of the people you see in this picture, but I wouldn't always understand everything that they did. But that's not allowed in modern authorship criteria, at least the ones that use the ICMJ criteria. There's another issue, which is that you can say, well, we can, let's just change the authorship criteria, loosen it, get rid of the writing thing as being required, and make a new list. But there's a major difficulty with that, which is that if you survey scientists across fields and across the world on any individual contribution type, you ask them whether that deserves authorship, you're going to get strong disagreement. Some people will say yes, that for some aspects that really deserves authorship, and other people will say no. So, for example, here you can see for this thing where they asked thousands of authors, would installation, I guess, of equipment, does that deserve authorship? You had a lot of people who said almost always, but then you also had a significant bunch of people who said almost never. And the same for a lot of these categories. You can see that you have both people that say that this always deserves authorship almost, and you have people who say this almost never deserves authorship. So I don't think it's realistic across many scientific fields to get agreement, or even maybe across countries. So that's a major difficulty with any criteria. Now it afflicts the original authorship idea as well, because that first criterion of major contribution to the work would have to reflect this. So I'm not going to suggest that we're going to come up with some master list of types of contributions that deserve authorship. And in fact, what's easy one year, what's hard one year might become easy the next. So, for example, if you look at this one, correcting grammar, yeah, most people say almost never, but there are a bunch of people who say almost always that deserves authorship. Now, this is before ChatGPT and large language models. Now I think this would get smaller and smaller. So if you make any list as technology advances, and of course it's not just about writing, other technologies advance for doing other tasks, you know, it's not going to be something that you need a person to do a lot of work for. So it's very hard to make a list. So this my talk is really more in the abstract to some extent, although I will show you a list later. But to overview what we've talked about so far, scientists really traffic in both their intellectual contributions and priorities. So, you know, the first person to discover something or show something, we want to give them credit. So that's part of what's going on here with authorship. But also there's just the practicality of we need to know who did what, both for fairness reasons and for efficient resource allocation. The traditional system of authorship, most people have not read those criteria very carefully, like I have, so they're probably widely violated and little understood. And even when people do read them, they vary widely in their interpretations. And also we have this problem that we'll call honorary authorship is rife, where like the senior member in a lab might get their name. When I was working as a postdoc in another lab, I had a friend who was a postdoc in that lab, and there were 18 postdocs in that lab. And you know, the lab head said, anything you all do, I should be an author. And so my poor postdoc friend, he would send the paper to the lab head, and like 3 months later, he'd be lucky if he got a few comments, and then his name, that guy's name, added to the list. And also traditional authorship doesn't reveal who did what. And if we want, as science has become specialized, we might need know for certain kinds of scientific projects, we need a very good gas chromatograph specialist, or someone who's very good at using multi-level models to do data analysis and such. And the resource allocators, be they universities or funders or lab heads that are trying to assemble a new team, can't see who the people are that made the most contributions in that area, because you just have a list of names after a paper. So part of changing this is going to be changing research culture, and some universities are already doing that. In that they've revised guidelines, like Glasgow has. So we could talk about that. I think that's an important role for things like the reproducibility networks, is to build these kind of statements into, like, for teamwork and stuff, supporting each other to succeed, rather than sort of the lab head hierarchical model. So I also think that shifting to contributorship will improve equity, diversity, and inclusion, because with the classic system where you just have like a lab head, you know, they get to decide essentially, or whoever the first author is sometimes, who gets to like comment on the paper. And you can't be an author supposedly unless you contribute to the writing. So if they just don't send you the manuscript, you know, to contribute to the writing, then you can't be an author. But by eliminating that requirement, you know, it becomes more obvious that a wider group of people deserve authorship. So you've probably seen by now at many journals that there has been movement in this direction. For example, at all of the PLOS journals, if you look at for example, a PLOS One article like this one, you'll see that underneath each person's name, there's a list of which categories of contribution they contributed to. So this is progress. Now, PLOS One, they still use a fairly traditional authorship criteria. So you can't get on this list unless, in theory, unless you contribute to the writing. So each of these people will have writing under their name. But at least it's also indicating something about what each person did, rather than just being a list of names. And what they're using there is called the credit taxonomy. So this was invented by some funders and biomedical researchers a few decades ago now, a little more than a decade, I think. And it stands for Contributor Roles Taxonomy. And so what those sort of biomedical oriented people came up with was 14 different categories for the studies that they thought of. when they try to divide up the sorts of categories of tasks that are done. And so, one way to move towards contributorship would just be to write down, exactly what each person did. And that's great because it provides the maximal amount of information. But one shortcoming of that is that it's hard to aggregate that across multiple papers. So unfortunately, we've got, these bureaucrats or funders that have to count things. And so if they know they want to create a new research institute that requires a lot of big data analysis, they know they need a lot of people who've contributed to maybe programming and software and statistics and such. So they need to be able to sum across papers to figure out with a particular CV, has this person contributed to particularly in the software category. So it helps to have these sorts of categories in order to do that. We're not going to get away from having to have metrics, for everything. That's the modern world. And so a lot of journals have adopted this. If you submit to eLife, you'll probably, that's a biology and some psychology journal. For each author, what you'll have to do is check which of the 14 boxes, which categories one contributed to. And then you can also add a more detailed description. So that covers both aspects of it. In the credit protocol, it's actually machine readable. In other words, when the publishers who have adopted it, which includes most of the major publishers, what they do is they have set up their system such that the list of who did what or which of the 14 categories they contributed to is included in what they call the JATS XML, like these structured HTML that any machine can read as it browses the web. And that way it can be aggregated by databases. And so here are some of the benefits that some people came up with in a word cloud in a workshop on credit. And I want to point out some interesting things about it. One is that I think it can, in a weird way, lead to a reduction in honorary authorship. So remember, honorary authorship is things like people getting their name on something, even though they didn't contribute to that particular project. But you'll see in the credit taxonomy, they include supervision, and they also include funding acquisition. So whereas before at that lab where there were 18 postdocs, in order, for the person, the head of lab, they had to feel like they could get the next grant and get the next round of 18 postdocs, they felt like they had to be an author on every one of the papers. And so they were basically lying by, putting their name on it because they didn't meet the authorship criteria. But now by moving to contributorship, they could just, we can make them honest and still have their name on the paper because they could just tick the funding acquisition box and maybe the supervision box and maybe the resources box. So that way we can thus allow them to be recognized and keep the practical aspect of the system going, which is unfortunately that some people have to spend all their time writing grants if they have a big lab. So rather than trying to beat honorary authorship, which a lot of societies have tried to do without success, I'd say just give up, but give these people like a way out. So that's one aspect of it. And as you start to recognize formally these, individual roles, and they get real recognition, then funders can see, oh, for all these different papers, we had someone who specialized in mainly contributed to the software. Okay, so now it becomes clear we need to hire more software people, and you only get that if you're really documenting this. So that's just a way that we can advance specialization and also meta science, so we can study what kinds of teams produce the best science, thanks to that information. So in order to get this sort of integrated with the scholarly system, one thing that has to happen is we want to make it easier for people to indicate this information, because now if you go to a journal, you have to enter all this information one by one for each author. And that can take a long time if you have a lot of authors. So that's again hindering specialization. It's hard to make a big team if you know you're going to have to do all this documentation work and you have to do it, when you submit to a journal. So I'm going to get back to this tool that we created because it's also actually, we got a small grant from the UK reproducibility network for this Tenzing tool. But first I want to say one more thing about team science. So you may have noticed like more and more very large collaborations happening over the last several years, especially sparked by COVID and the ability to use Zoom and things like that. And so people have started studying this, like Sophia Folk, and she's gone to like teams that have lots and lots of collaborators, like many dozens of collaborators. And she's described the challenges. Now, these are challenges probably for any collaboration, but they're particularly bad for like large teams. So she gave a talk at this big team science conference that I attended online, and you know, just highlighted one of the challenges there, which is unclear division of tasks. So actually, this contributorship thing, because it encourages people to document tasks, it can actually help with this because you know you're going to have to do it. So that sort of pushes team researchers a bit to, you know, start towards the beginning of the project thinking about what these things are going to be more, because they know they're going to have to at least write them down at the end. So let me show you this little piece of software. Can you still see can you see my web browser?
No, I think you were only showing the presentation.
Okay, yeah, so I'm gonna, okay, let's share the whole screen because yeah, you're right. Okay, can you see this web page now?
Yes.
So it was mainly Martin Kovac, who was pictured, who's created this web app. What we're trying to do is integrate contributorship into researchers' workflow. So another, you know, problem with team science is that the unclear division of tasks means that you get more and more like authorship disputes where because, you know, where people because they didn't think to like work out exactly what everyone's doing at the beginning, there's a bunch of misunderstandings because it wasn't formalized, and then at the end you have authorship disputes, or even if you don't have disputes, you know, you have less efficient work. So we want to, so currently you only have to worry about this when you actually submit to the journal, because that's when you have to click on those 14 credit things. We want to move that like backwards in time, earlier in the chain, and also facilitate it, entering it in the journal. So we created this website that we call Tenzing. It's just this free open source website. So what the way you're to use it is you click on that table, and then we've got currently just this Google Sheet where the idea is that you enter what you can do is you send it around to all of your co-authors, and you could tell that you could do that towards the beginning of the project and say, listen, you know, we should be planning on what we're going to be doing, each of us dividing up the tasks, and also we're going to have to probably enter this information anyway at the end. So why don't you fill out tentatively which aspects do you think you're going to be contributing to, and that can facilitate the discussion. And then the idea is that you then tick these boxes and such. And then later, when it comes time to submit to a journal, hopefully you've gotten all of your collaborators to also indicate the other things that you need, like their primary affiliation, and their email address and their ORCID number and so on. So then if I go back, then the idea is that you can load the spreadsheet into the website. And what we do is we'll output for you the text that you might need for the title page of your manuscript. So and we've got different options for this, or this might go in the author note depending upon the journal. And you can download this, and this, you know, is also helpful for people's title page. We got all the footnotes and so on, and the affiliations. But the real dream for this is to not only make it easier to create your Word document or whatever it is, but also to prevent you from having to enter the information again when you submit to a journal. So the way it's actually encoded in the journal, once you've entered it all in, is as JETS XML, basically this kind of coding. And so ideally, you would just be able to upload this to the journal when you submit. So you wouldn't have to do it hand by hand, because for example, with the Psychological Science Accelerator, I was talking to Erin Buchanan, who's submitted some papers with more than 100 authors. And for one of them, she said it took her like 6 hours to just to enter mostly the authorship information, she said. So this is really untenable. But unfortunately, we haven't been able to convince yet any journal management system providers to do this. But I mean, the open source ones are open to it, but we need to get money to be able to pay to program that. So that's just this, the vision here is that we want this contributorship concept to be built into researchers' workflow from the beginning, dividing up tasks, specializing. And when you're talking about how that's done, you know, like in an industry or anywhere else besides science, when you have large teams, people tend to use project management tools. I hope you can see my slide again. So and here's a few examples of project management tools that, you know, haven't been used in science much yet, but I think that's the future. And this also hooks into other ways that a lot of us want to reform science, which is not have the journal article be everything, not have nothing appear until the journal article gets published, or even have nothing appear until the preprint gets published. We recognize that science, you know, happens in pieces. There's data collection, there's the protocol, and so on. And there's things like Octopus and Research Equals, that's this one, that have gotten some money from funders to have science be more incremental and have parts of the science appear as you go along, as opposed to just waiting till the very end and writing it up as this just in words, and then having to do all the data sharing and stuff as an afterthought, which often doesn't happen. So that's sort of how all this fits into the bigger ecosystem of science, I think. So that's all I wanted to say. Thank you.
Thank you. Thank you very much, Alex. It was a really interesting talk. So let's start with the Q&A session. I've already seen that Sarah has raised her hand. So Sarah, if you want to ask your question.
Well, actually, it was a mistake. I was looking for how to clap my hands, but I can do this here. It's on Zoom, probably, or yeah.
Okay, sorry.
But that's okay. I mean, I can just take the chance to thank Alex for the very nice talk. It was really interesting, and I'm just happy to say that at least in my experience, not everywhere is that bad. I don't know, because in our lab, I completely agree with everything you said, and I am aware of the fact that in most of the labs, you do get the credit, you do get authorship only if you contributed to the intellectual part, which, I mean, I don't think is completely wrong. It's wrong if that's the only reason why. I mean, still, I think the intellectual part is still the most important part of a paper, because we don't have to be technicians only. We need to have a reason why. I mean, I don't like the idea that we need to be specialized because we have to produce more. I think that we have to produce more if it makes sense, if there is, you know, a reason why going towards that direction and running that piece of research, not just doing because we can. But also I agree that, I mean, we can never be the case that we can all be, you know, expert at the same level in all the different things that today's research requires. So, for example, in my lab, we've always given credit to authorship, even to people that just contributed a lot to data collection or to data analysis or just funding acquisition. So I mean, I think that there can be some happy examples in which, I mean, people do realize that, I mean, every little piece is needed for research. But yeah, this tool that you proposed, I think it's very useful for understanding even more that that's always the case.
Yeah, thanks for your thoughts and sharing those experiences. Yeah, I think a lot of people, you might be violating the, the authorship criteria, your lab for some journals, but yeah, a lot of people, I mean, a lot of people are doing that. And I think, yeah, so if we can change the formal aspect of it, then we can encourage more people to do the sort of things that sounds like your lab is doing well.
I see Julia has a raised hand as well.
Yeah, thank you, Alex. Can you hear me? Yeah, I think, yeah. Thank you for the very stimulating talk. I was wondering, how can this approach to recognizing individual work effectively indeed combat authorship misattribution? I mean, lab leaders or PI can still request to be included as contributors, even if they have contributed very little. And so how can this approach truly reduce the gift of authorship to those at the top of the hierarchy, I mean?
Sure.
Yeah.
Yeah, no, that's not easy. I'm not, and there's, so yeah, but just to reiterate, like the small aspect of this that can help with that, but it's only a small part of it. Yeah, currently the system is not set up at all to for the reality of science funding in many countries of large labs having like a head who spends all the time writing grants. So with this contributor system, it's more accommodating to that. So people can, if those lab heads who want to be honest, which is obviously not all of them, can continue to do that sort of thing and be honest by just clicking on the resources or supervision or funding acquisition categories. But as you say, there's going to still be people who abuse their power by indicating that, and thus if they have power over the junior people in the lab, there's nothing you can do about that idea in a sense. So a lot of that's just culture change, right? So and I think we've seen a lot of progress in reduction in hierarchies across most Western societies over the last few decades. I mean, just the equity, diversity, and inclusion stuff that we hear a lot about is, just one element of that. If you go back a few decades, even before anyone thought of those phrases, you started with like the big professor, and everybody addressed them as sir, and there was never any use of first names or anything. So that, like, society just broadly has become more and more, I think, less hierarchical. And I think it's that kind of cultural change that a lot of people are continuing to push. That's the main ingredient. And also greater accountability. So we've also seen over the decades, there were people, of course, who abused their position in even worse ways, like sexual harassment and so on. And they almost always got away with it. And now we see more and more that the universities will do something about some of those people. So there's the accountability part too, where a whistleblower or someone who's a junior person in the lab can feel comfortable as both the culture changes and the procedures change at universities. They can feel comfortable going to someone else and feeling like they're not going to get punished because that person isn't going to talk back to their lab head. It's very hard to eliminate that concern. But for example, in Australia, we have each university has these research integrity advisors across the university. And so I'm one, and the idea is to have one in many different departments so that someone can go to a very different department with their concerns. And so you get some, at least, lack of nepotistic connection between those people. So there's a lot of things like that, I think.
Okay, I know that Vittorio had a question. I'm not seeing any other questions written down or raised hands, so I think, Vittorio, if you want to ask your question.
Hello. Can you hear me?
Yes.
Yep.
Yeah. My point was whether you think, or I would ask your takes about tools. So whether adopting different tools for both for writing or for organizing scientific projects could drive contributorship recognition. I mean, if you start writing your papers with R or with GitHub, then it's clear who pulled the request and who did the commit and so on and so forth.
Yeah.
But at the same time, I know that so writing down a manuscript, it's also a way to like take a picture of the project in that moment, put a timestamp, gatekeep what scientists take in that moment. So maybe even if I think somehow that it could be interesting to adopt different tools in writing, then I recognize the importance of the manuscript. So I cannot really decide and wanted to know what you think about this.
Right. Yeah. No. But thank you for mentioning that. I wanted to say, yeah, GitHub, works so well for certain things. So like the dream is like in computer programming, where software developers, every single little contribution they make gets recorded on GitHub, and thus automatically you've got this ideally perfect, great record of exactly who did what, down to individual, characters that they changed on every line of code. So unfortunately, science has much more diverse tasks than that. But yeah, I think we should be moving in that direction roughly. So, more and more of the data collection, scientific equipment is connected to the internet, so it will, generate records and it'll indicate who used it and so on. So you can imagine the sort of GitHub thing moving beyond just the writing contributions and the programming contributions. But there's always going to be some things left out. So even in the software developer community, of course, they've recognized for a long time that there's a problem that, women are very underrepresented in these things, some of these software development projects. But on the other hand, women might be overrepresented in like the community organizing and stuff, which isn't captured by GitHub. So when you have a very technical solution, it's only capturing one element, and then they've tried to figure out how can they capture these other sorts of contributions that are necessary for any project to succeed, but don't come down to like lines of code. So yeah, it's going to be a struggle, and but yeah, currently we have nothing. So I think almost. So like even GitHub is something that helps. You can also use it, for task management, but that or any other project management thing that provides a little bit of a paper trail or a computer file trail of what's been done is going to help.
While we wait for any other questions, I would like to sort of latch onto this kind of argument. And while I was listening, what I was thinking about is that I have, especially recently, or as I grew up from a student to PhD to young postdoc, several people, professors or supervisors, telling me and in a way complaining that as they grew in their work position, so professionally speaking, that they had less time to do what they actually liked, because they needed to focus more on getting funds, organizing the groups, supervising other people, teaching. So I wanted to know your opinion on how long. Okay, what I thought was if we change the way in which we recognize the contributorship to projects, of course, in a way, there's still going to be a need for people who are more advanced in their career or generally it happens to be the people who are more advanced in their career who take on the responsibility for actually putting together a team, getting the funds, managing the team, rather than, I don't know, dedicating themselves firsthand to data analysis or data collection or whatever it was that had them passionate when they started off. Do you think this is going to be less? Okay, there are going to be alternatives. So maybe if my passion is data analysis, I'm going to be able to keep dedicating time to that, because someone else, maybe equally advanced in his or her career as I am, will be taking care of other parts, and I'll be able to be I don't know, a professor, but still focusing mostly on data analysis and not on writing grants, because somebody else I work with is really good at writing grants. They love it. They're good at it. And they can write the grants while I do the data analysis. Or do you think that's going to happen anytime soon?
Not soon, but yeah, I think this will help with that. Yeah, first of all, yeah, there's the issue that currently there is no way for the funders that decide what we have to do in our jobs to see the advantages of specialization. So this is going to help with that. But I don't know if it completely will, because there seems to be a very broad problem that, at least at the universities I've been involved in, the burden of administrative tasks, to get anything done, hire a new postdoc, get a new student onboarded, get a travel claim, or equipment purchase reimbursed, that kind of stuff, is because of these technology systems we have at the universities, the management seems to push those onto a lot of work onto us for that. So it just seems that so the contributorship will help, but there's the question of whether sociologically there's some other obstacle besides just being able to see in the data that the most efficient use of your time, the most productive use of your time, I should say, is data analysis, not filling out forms and stuff. So that there has been some movement towards that, I've noticed, especially in the US recently. A while ago, the funder created this thing called Genelia Farm, the HHMI Institute, Howard Hughes Medical Institute. They were recognizing that one of the reasons that scientists aren't very productive is not only because of all those administrative tasks they have to do, but also the grant writing you mentioned is because the grants are at such a short time scale that you always have to write grants because you never get a grant for 10 years. So what they did is they created this research institute where they would give people unconditional funding for a much longer period. And a lot of countries have that for a small central government scientific institute. But I think we need more of that to, allow scientists to become more productive. And especially in the US, where there's a lot of billionaires who like to, experiment. There have been some other experiments like that that have cropped up because people have been more unhappy with NIH because of how bureaucratic that is. And they've said, well, I just want to give a whole lot of money to, a really good scientist. But then, there's not only, so then we also need to recognize the support staff and capture all the administrative and sort of support things that are being done so that aspect gets adequate funding. If that requires people, then we need to record that so that the universities and the funders will realize we need to spend, when we give someone a grant, we shouldn't just give them the money for the postdoc and the PI, but we need to give them money for this amount of support staff people.
Thank you very much for your answer and for your talk again. I didn't have a chance to say it earlier, but it was really interesting also to find out about the Tenzing. I'd met the credit model in submission, but the Tenzing looks like a really nice tool also to save time in all the back and forth. Can you please everybody check their affiliation and so on? So I think
there's so little
definitely
funding,
going to use that from now on.
Yeah, there's so many little things like that that could be done to improve our productivity, but there's these things aren't funded very well, scientific software.
We have a few more minutes, so if anybody has comments or questions, go ahead, people. Okay. Sorry, I keep switching back and forth because I cannot see everyone on the same screen if they raise their hands or speak. But...
Well, in any case, I want to thank you again for the invitation. It was great to hear many of your thoughts. And yeah, if you have any other thoughts later too, please email me.
Well, thank you very much, Alex. Again, it was really, really nice to have you here, and your talk was really interesting. I just want to, to wrap up this today's seminar and give you the last information. So if you are a PhD student and you ask for the certificate of attendance to this seminar, we will send you an email within the 7 next day. And that will be the only certificate we are going to send you. So we're not sending any other forms of certificate of attendance. And next month speaker, we will have our last seminars of this year. And the speaker will be Joanna Cristea, who is going to present a presentation entitled Redesigning Incentives, Open Science Practices at the Cornerstone of Academic Evaluation. And finally, again, if you want to support all of our initiatives and the Italian Reproducibility Network, you can become a member of the association, or you can subscribe to our mailing list or join our YouTube channel, where you can find all the seminars that we took in these last 2 years. Again, thank you very much, Alex, for being here today, and good afternoon, everybody.
My pleasure. Thank you.
Thank you. Bye. Bye, everyone.
Bye-bye.